All right, all right. Let's do this. All right, guys, it's time. So, I just received this free treadmill, and it has a problem. So, this treadmill, apparently, somebody was walking on it, and a child came up and they had a ball that went underneath it. I don't know how. I guess it went underneath it, bound it up, and now the treadmill is not working. So here we go. I know absolutely nothing about this other than the fact the tilt motor works, the control panel powers up, and that's it. That's pretty much it. My estimate for this treadmill is it was worth about $4,000. Um, Now I've got it here in my shop, my living room actually. It was a bear. It took me a long time to get this in the house because it's like an inch too wide. I had to tilt it over. It's probably 300 or so pounds. It was a monster. But here we are. So let's do this. I'm going to reposition the camera and get you guys a good view straight down into what's going on. And meanwhile, I this time here, I do have the ability to keep track of the chat. So guys, I will be monitoring if you guys have any other questions or anything, but let's see. So this is one of the things I'd really like to do more often on this channel is to show you guys live step by step how to go ahead and fix things, because it's the process of fixing things, it's the process of troubleshooting that's the most difficult thing to relay to junior level people, junior level technicians. So this is why I really believe firmly in having interns, so that they can see the process. But right now I don't have interns. They're all busy techs. So let's go ahead and get right into this, guys. I've already taken the cover fasteners off. That's as far as I've gone on this guy. And so here I've got two top screws and I've got one in the front. Almost all treadmills are easy to take off the cover, almost all of them, because it is a device that needs to be routinely cleaned out and it needs to be routinely checked out. So let's go. All right, let me go ahead and place the cover over here, and I'll move the camera so that you guys have a much better look at what's going on. All right. All right. What do we have? Would it be easier for me to do it over this way? Sorry, guys, if you're getting motion sick. I'll put you a top-down look from on the belt. All right. There we go. Oops, sorry. Okay. That's not too much in my way. We'll be good. All right. So the unit is currently plugged in. And to help me out, I'm just going to use a regular multimeter for the time being. For this job here, I'm going to need a flat blade screwdriver. I think that's going to be it. So this is obviously your drive motor. You can see that when I move it, it goes back and forth. This here is a timing mark, and this mark here allows you to calibrate the speed. So if you ever did have the ability to do a calibration, you'd use a photo tack on this guy and get your speeds. This here is your inclination motor. It's a linear actuator. It's a stubby little guy, but it works. Let's see. Let me get you a better view of these power boards. All right, so I'm going to use a flat blade because we are going to inspect some brushes. And let's see, what do we have over here? I have a power transformer. So this one's actually a really nice power transformer because it has it labeled 12 volt out, 110 volt in. We don't need to inspect that because it is powering up. And they said that this motor here does work. And I'm going to break rule number 1 of troubleshooting, and that is to never ever trust somebody else's troubleshooting. But I did plug it in, and when I plugged it in, I did hear it beep. So that tells me that the console does have power. No need to check the transformer. Um, so I have no schematics on this guy, but I'll tell you right now that I've got my 12 volt coming in right here, and there's something underneath the shield, which I would assume is a relay. You've got some power MOSFETs right up here, and these ones here should be your drive circuit for the main motor right there. And I've got some relays right here and right here. Those should be the clickety clacks for, I would assume, this guy or the emergency shutoff, the e-stop. On all treadmills, there is a magnetic or a micro switch based um, runner detect, I guess you can call it. And normally, when you're running, you're supposed to clip it on you. And when you fall off the treadmill, it yanks it out and that stops the treadmill. It's possible that that sensor could be part of the problem. We don't know yet. All I'm doing is a physical inspection right now to make sure that this guy is not going to catch on fire, because that would be really nice. Oh, so a couple other things to take notice of. Let's see if you guys can see it. So right here, these wires, is this the AC mains coming in? I think so. These wires have been crimped really badly. So whenever you take the cover off a treadmill, check your wires, check your cabling, because you don't know the history of the device. And here I can tell that somebody else has been in here goofing around. And when they put the covers back on, they didn't put the covers on very well. And that left some wires crimped. That's not a good thing. Last thing you want is that hot wire to be crimped against the chassis. I mean, this is a treadmill, it vibrates. That means that wires will get wore out. All right, so let's see. Okay, so here is what I think is AC mains in. Okay. And after AC mains, I like how they did this. Right here is a bridge rectifier, but it's inverted and it's through the PCB. Here, can you guys see it? How about that if I bring the light back a little bit? So right here is the bridge rectifier. That means that this is your mains, and your bridge right here, it's inverted and it comes through the PCB. The AC is going to be the leg that's got the fuse right here. The DC is going to be the leg that goes to your main capacitor. So that one right there is going to be one of the DCs, and adjacent to it, that's going to be your other DC, this one over here. So I could measure the DC off of that. It doesn't matter because, as I said, the control panel is powering up, so we're good there. Let's see what else we got going on down here. This all looks really good. So this right here is your DC switch mode power supply. This right here on this heatsink, these are, there's probably a rectifying diode and then a couple power MOSFETs for your drive. That is the area that's in question here, okay? Let's see, I've got two other, what are these? C78 120V. I'll have to look those guys up. And let's see, all this looks really good. So normally when something blows out, you're looking for a component that got overheated, or you're looking for a little bit of charcoal. I don't see any of that on these. No, it looks really good. Okay. So that's interesting. There's two DC power supplies on this. These white wires right here, they come over and they go to the bridge rectifier, which is inverted. And they're inverting it so they can use the metal mounting plate right here. The metal mounting plate is the heatsink for it. So that way there can handle more watts. So this is the first DC power supply. And then the second one comes off this 12 volt transformer right here. So you guys should know that transformers can only handle AC. So if you see a transformer, you know you're measuring AC. So this would be my second power supply coming over here. So I bet you the 12-volt power supply on this side right here is handling the control panel. And I bet you that this guy over here, since it's inverted, it's mounted to the plate, this one over here is the main 12-volt power source for my motor. So that tells me I have two places to measure. Let's go ahead and see, is it on? Okay, you can hear it. It's on. Let me go ahead and set my meter up. So I should have DC power here off the bridge, and then I should have, there's a full bridge over here. It's an array of 4 little diodes. So I also have there where I can measure. Let's see, I'm going to put my meter over here. Don't worry, guys. I'll find you a better place where you can see all my readings. About right there. Okay. So first thing I'm going to do is go into DC right off of this inverted bridge. Check that out. 165 volts DC. That guy is working fine. And this guy over here, should I even check it? Because this guy over here is almost definitely for the light loads. They're purposely decreasing the voltage with this. This is a reduction transformer. Yep. Interesting. Okay. Down to here, and I have no access from the top of this. But that's okay. Tell you what I'm going to do. Let's see. These right here are the wires for the motor. And I see 2 wires. So that means that this guy is not a 3-phase motor. Okay. So one of the things that will difference commercial grade machines to the normal consumer grade is that they almost always use 3-phase motors. This one here is a 2-phase. Let's go ahead and inspect the brush. The machine is not running. It's powered up. So let's shut the power off. Let's go ahead and pull that brush out. So that means that there's another brush on the other side. It's on the bottom. The belt would have to flip up, and that would that would give me access to this other one if I flip the belt up. So here's the brush. The brush is nice and smooth. It looks really good. So that tells me that this motor is not burnt. Let's go ahead and take a look down at the rotor and the commutator bars. So the cool thing about this being a treadmill is that we can grab the wheel, the flywheel right here, and we can spin it and take a look down there at those commutator bars and take a look and see what condition they're in. So if you see pitting or bridging, which bridging is when they're arced and they're kind of melted together, that usually tells you that you got other problems. Now these bars look beautiful, and I expected that because the brush, the shape of the brush is perfect. So let's go ahead and put that guy back in, nice and easy. And this is not the type of brush that holds itself in very well, unfortunately. So you got to use 2 hands. Come on, get in there. The brush wants to fit out of its seat. There we go. Cool. So notice how I went backwards until I felt the thread pop, and then I went forward. Don't cross thread these brush caps. You want that to have as secure threading as possible. Okay, so let's see. We got this, we got this, we got this. So these right here are my motor leads. I don't have my jumpers. So how dangerous could this be, right? So if I get arcy sparked right here, you guys will know I did something wrong. All right, here we go. Ready? Get my meter out of there. Okay, let's see. We'll start. 3, 2, 1, go. Oh, cool. I can hear it. I can hear it. That's a good sign. So stop. Okay. So what I was listening to is these little SCRs right here. I was listening to these guys. They were buzzing away, which means that they've got voltage and they're doing their job. So now I got to think, what else could possibly be going wrong? There's nothing binding up in here. The belt seems to be good. The motor didn't even really look like it was trying, though, did it? Normally, you'd see the camera jerk or something when I hit start. Here, let's do that again. Let's go. 3, 2, 1, start. Nope. Okay. So these guys up here are in question. Let's take these two off. Okay, so right here it says M plus, M minus. Let's see if I can put my light there, if you can see it. Okay, M minus. Check. M plus. Whoa! Yo! All right, let's try this again. Let's make sure I didn't pop a fuse. 3, 2, 1. Nope, didn't pop a fuse. All right. Cool. All right. Tell you what, give me just a second. I'm going to go get some proper. All right. Well, we know that there's power there, huh? I need to go and get some proper jacks so that I can connect up properly and there's no risk. Bjorn thinks a faulty relay. Well, Bjorn, I can tell you this. If there's a faulty relay, I don't think I would have a spark. I can hear the SCRs kicking on for sure. No problem there. Well, I didn't check the other brush though. And I did see a lot of brush powder come out right here. So let's see. Give me just a moment to get some cables. All right. There we go. Let's do this properly this time. No more sparks. Okay, let's see. We got M plus, M minus. M minus right here. Oh, right there. Can you guys see it? Okay. What? I just noticed the end of my lead was a little bit melted from that little arcy spark. Okay. Next, let's do the M plus and connect him up. All right. Normally, if I was in my shop, I would have done this the safe way, but I figured for time's sake, I was going to skip out, and look what it got me on. Okay, so here's my meter. Whoa, whoa, whoa. Okay. There you go. Okay, so there's my meter, and my leads are set. Everything should be safe. And we're on DC. Three, two, one, go. Okay, I'm currently turning up the speed, and you can see that I am not getting what I should be getting. Okay. Shut it back off. So now my SCRs are in question. Those little guys right there. And unfortunately, this board, because of the heat sinking that's currently being done on that, didn't pop that guy, did it? Huh. Because this full wave bridge rectifier right here is inverted and it's being used as a heat sink, that means that this board is going to be a little bit more of a challenge to troubleshoot. So what I'm going to have to do is I'm going to have to take this guy right here off. Tell you what, let's just take that whole board off. Just pop that whole board out. I can't even take measurements with it sitting there like that. Sparks is a sign of voltage present. You're right there. Oh my gosh. Life delights. Good to see you. And Gidalaru. Hello, sir. Hello to you. All right. Well, let's go ahead and take a look at this board. All right, so let's go ahead and pull the power cord. Now, mind you, there is probably going to be some voltage on this bad boy. So you've got to be aware of that. So this board, first I'm going to pull this one right here. It's securing all my cables because I want to be able to manipulate the board and move it around. All right, here we go. All right, so here's something that I do that's a little bit different than a lot of people. Try and put the fasteners back loosely in the hole that I found it at. Okay, so I have one dark fastener right here. This guy is holding it down, and yep, I got one right there. So that should move the whole heat sink platter with me. Those feel a little odd. Okay. Wow, this thing definitely needs some cleaning, huh? I just picked this up for free today, guys. So this was it's one of those Facebook Marketplace finds, and the family, they didn't want to deal with it at all. They just wanted to get rid of it. So technically, I'm pretty certain it's going to be this board right here. All right, come here, you. Let's go ahead and pull this last screw. There we go. Because they just screw these into sheet metal, it's like sometimes if you can't get it out, you just put some force on it and it'll kind of pull it up. All right, what do we have here? I guess that would be, yes, CE compliance. All right, no problem there. So there's an underside of this board that I'm really curious about. Make sure that no tracks or anything were blown out when the kid's ball went up and underneath it. You would think that it would have a resettable fuse or something, you know, to keep things from going out hardcore, but I guess it gets them the ability to buy another board, right? Okay. So I'm still curious what this guy is. All right. All right. Let's see, I can't really see the holes. All right, for my sake, I'm going to just thread this screw in real quick so I don't go crazy. And now I want to check this motor. So let's go ahead and grab our meter. I can't see the other lead. That's okay. Let's put this motor here on ohms. Okay. So here's something. Checking the coils on a motor. Because the brushes are going over those commutator bars, you're going to get a change. And see how it goes back down to 1. That's good. And you could technically do this if you got dead spots, even if you didn't have access to your commutator bars to take a look at them physically. You could do this exact same process. So you just hook your meter up to the wires coming out of your coils and then just rotate it. And if you got any dead spots, you see how it goes really high and then when I stop moving, it goes down to 1. Well, you're going to see where it's going to be like 100 or 200 ohms or even a kilo ohm. And that's going to show you that your commutator bars in that particular region are damaged or your coil's damaged. This looks good. Yeah, I think as the camera gets further away. Okay, well, I did a physical inspection now already, and it looked really good. So there's not even really a need to check that lower brush because it's obviously got good contact. Other words, I wouldn't be down at 1 ohm. All right, so let's see. So this board right here, normally I would just replace this board. Obviously, your motor's being powered off this board. Right here is your power MOSFETs that are juicing it up. Let's see. L1, L2, come on. So this could be just a $89 board or something like that. Who knows? Come on. Of course, it's going to give me a hard time now. So I had to lift up on it because these are self-tapping screws. And self-tapping screws with sheet metal, they're always a pain. Okay, so here is the bad part, no matter what. We could probably fix this part itself. In order to do that, what I've got to do is I got to take this bar off right here that is holding all these to that. It's obviously not right now. It's obviously not shorted out because it didn't pop any fuses. Right here's your main AC fuse. Is not shorted, so that tells me that they're somewhat good. I can't visually see any damaged traces on there, but this is just one of those times where just because you have voltage doesn't mean you have doesn't mean you have current, or you have to have switching. All right, and that's how it controls the speed of this guy. Is it's using pulse width modulation, PWM, and it's going to pulse the voltage faster and faster, and that is what's going to allow the motor to speed up. Let's go ahead and take this guy off. The board's bad anyway, right? Some of you guys are probably waiting for me to get popped because this guy's probably still got voltage on it, to which I do not disagree. All right. Come on. So that's what I'm doing is I'm pulling off this bar right here. And that bar is what is pressing those MOSFETs against the aluminum for heatsink. But it's also keeping the board from coming out. So, you know, things normally fail in a short or in an open. And I am thinking in this case that I have an open someplace because reasons. Okay, so this last one that I'm pulling out, this is the one for the bridge rectifier right here. It's securing it to the bottom. Ooh, well, that was easy. All right. So here's where I just got to be careful. So I'm just grabbing on this housing right here. So the underside of this board looks pretty good. What I'm kind of expecting is one of these solder joints to have gotten hot, and I will now have a socket that is basically a cold solder joint. There's a little bit of splatter right here by this post. It looks like solder splatter right there. And I'll have to put this guy under the microscope. So the other thing I have to do is check these guys right here. One of them is going to be a rectifier, and one of them is going to be power MOSFETs for pushing that pin right there. Okay. Well, this is an old board too. I can see that it's from 2001. Okay. Well, there's a little bit of bridging over here. And I do see some solder splatter. And that usually happens when something gets really hot. So I've actually had this problem before with what is it, the force triads. And with the force triads, what it did is it created a hole near the socket. So what I had to do is reflow the solder. There, now you can see it a little bit better, right, guys? Okay. So this board looks like it's okay. I'm going to price it out, take a look at it, and see what is all going on. I might be able to buy that whole board. But anyway, this one right here is probably handling your safety circuitry, which is, like I said, your e-stop and stuff like that. It's also handling some of the power. I can see that this one also has a power circuit over here. So it's got a little power supply, but it has nothing to do with the motor. So that's why I'm not checking it, guys. Okay, so I can tell that this motor right here is being powered by this board completely. Right here's the leads. And here's something else that's interesting, guys. This is a 3-wire. So this one here is a 3-phase motor. See this right here? You got white, red, and black. So this is a 3-phase, which means there's going to be a chopper driver up here. No biggie. It's probably piggybacking its voltage off this board down here. So the mains came into this one, then it split it off, and it had a little DC circuit very similar to right here. Oh, you can see it over on this side. So the 12 volt off this guy comes in, and it goes right here over these diodes. And anytime you see a large capacitor like that, it's usually a smoothing capacitor. And so this creates one of your DC rails. And this guy over here creates your high voltage DC rail, that bridge rectifier right there, which goes right here into this capacitor. And look what's inside the shield. How crazy is that? I see a line of pins in there. So there's 5, 6, 7 pins. Wow. All right. Well, maybe I'll have to take that shield off and see what's going on in there. What I think is that that's a switching circuit, because the shield keeps the EMF energy from going and affecting other things. So I think whatever is right here is doing a lot of switching, and that's why they got it inside this metal canister. Really, you can see that it's soldered, and it goes to the ground plane right there, where the negative plane. Yeah, goes right here off the negative plane to that switch mode, or the geez, I can't even talk today, guys. Off the full wave bridge rectifier. But no, the board itself, this is the defective part. I will probably do a follow-up video showing you guys what's going on. Oi, as you get older, it gets harder sitting on the ground, guys. There we go. So, not too bad. Probably could have done that a little bit faster if I wasn't sitting on the ground, but this board is obviously the problem. But what I am going to do is I'm going to desolder these chips right here, these power MOSFETs, and we are going to check those out and see if they're working or if they're not. Yeah, there's nothing else that really sticks out to me, but this is definitely the problem. So guys, not to cut this short, but it is Independence Day, and my family and I, we are definitely going to try and chill out a little bit, although I've had my stress for the day just trying to get this in the house. It was pretty stressful. I had to tilt it over, and it's easily all of 300 pounds plus, and I had to get it through my doorway, which is not easy. But anyway, guys, I'm going to chill out. My back is absolutely killing me right now. So thank you all for participating in the stream, and we will probably give you some follow-up when I figure out what's going on with this board. I'm gonna need my microscope and my soldering station, which is off at work. So I'm gonna desolder some stuff and then check the values. And if anything, it's like a good rule of thumb that your diodes and your MOSFETs, just change them out, and then check and make sure that there's no shorts, which this was never a short in the beginning. So that's cool. But guys, I honestly don't think this is that expensive a board either. I can probably find one off eBay, or I'll just repair it. I mean, take a look. It's not that hard of a board to repair, although I don't know what's under here, right? So this is just one of those times where voltage does not equal current. We had voltage, it archy sparked. There was no current or no pathway. So voltage was going out. We can't verify anything was coming back. And because of that, no spinny spin. So You guys have a wonderful Independence Day, okay? Thanks for watching, guys.